In our previous lecture, we have learnt about intramolecular hydrogen, intermolecular hydrogen abstraction reactions. In this lecture, we shall learn about intermolecular hydrogen abstraction reactions of carbonyl compounds. Intramolecular means within the molecule. Intermolecular means between two molecules. So here we shall learn about intramolecular hydrogen abstraction reactions of carbonyl compounds. Here acyclic ketones or aldehydes, which are carbonyl compounds, will abstract H atom in both singlet and triplet excited states. But aromatic carbonyl compounds will abstract hydrogen atom only in triplet state. So this point has to be noted. Upon irradiation by UV light, carbonyl compounds will form alkoxy radicals. This alkoxy radical will abstract H atom within itself, that is intramolecular, to give us products. Let us see a few examples. First of all, we will consider gamma hydrogen abstraction reactions. These gamma hydrogen abstraction reactions are also called as Norris type 2 reactions. Let's consider an example of pentanone. Pentanone means 5 carbon atoms. 1, 2, 3, 4, 5. 5 carbon atoms with carbonyl functional group, that is C double bond O. So it is called pentanone. This pentanone has a gamma hydrogen attached to a gamma carbon atom. This is the functional group. C double bond O is the functional group. This is alpha carbon, this is beta carbon, and this is gamma carbon. To the gamma carbon, 3 hydrogen atoms are attached. 2 we have represented in green color and 1 we have represented in orange color to show it separately. This is the gamma hydrogen. In fact, any of these 3 hydrogens can be abstracted, but we are taking 1 hydrogen atom separately to show the reaction. When this compound is irradiated by UV light, it undergoes N to pi star excitation and enters singlet state. From there it may enter triplet state or it may remain in singlet state, and the reaction will take place in singlet state itself, because as we have already seen, acyclic ketones can undergo hydrogen abstraction both in singlet and triplet states. Here the pi bond between carbon and oxygen is cleaved homolytically to give us an alkoxy radical. This is the alkoxy radical. CH3 C radical, O radical, CH2, CH2, CH2 and H. This is the gamma hydrogen. This alkoxy radical is formed first. Then the gamma hydrogen and gamma carbon bond will start cleaving, as a result of which the gamma hydrogen is attached both to the oxygen radical as well as gamma carbon atom. This gives us a cyclic product. This is called 6-membered transition state. 6 members because let us count from oxygen. 1, this carbon is 2, this carbon is 3, This carbon is 4 and this carbon is 5 and this hydrogen is 6. So this is 6-member transition state. So this is a cyclic intermediate state. Then the bond between gamma hydrogen and gamma carbon atom cleaves completely, and the oxygen abstracts this gamma hydrogen totally. So as a result of which we get 1,4 biradical. This is the first carbon atom 1 with the radical 2, 3, 4. This fourth carbon atom also has a radical because it has given off the hydrogen atom here. So this is called 1,4 biradical. So in short we can say alkoxy radical abstracts gamma hydrogen atom to form 1,4 biradical. Now we shall see what happens to this 1,4 biradical. This is the 1,4 biradical. CH3, C radical, OH, CH2, CH2, CH2 radical. This is 1, 2, 3, 4. This is 1,4 biradical. This 1,4 biradical can undergo two types of reactions. One is beta cleavage, that is Norris type 2 reaction. Beta cleavage means the bond between alpha carbon and beta carbon undergoes cleavage to give us products. And second type of reaction is cyclization of 1,4 biradical. First let us see beta cleavage or Norris type 2 reaction. Here the beta bond between alpha carbon and beta carbon cleaves, forming two radicals. One radical is formed on alpha carbon and another radical is formed on beta carbon. This gamma carbon already has a radical. So these two radicals will join together to form a new bond, thereby giving us CH2 double bond CH2. This is ethene. So these two carbon atoms, CH2 radical, these two radicals will join to form a new bond. This new bond is represented in red ink. So we get ethene. Then this carbon already has a radical. Alpha carbon got a radical, new radical. These two radicals will join together to form a double bond, another bond that is represented in red ink. So we get CH3 COH double bond CH2. This is enol. This enol undergoes tautomerization and forms ketone, that is acetone. This tautomerization means this hydrogen atom which is present here will go and join this CH2 to form CH3, as a result of which we get CH3 C double bond O and CH3. This is a ketonic form of the enol. This is acetone. This is the major product. Now let us see the cyclization reaction of this 1,4 biradical. This is the 1,4 biradical. The first radical and the fourth radical will join together to form a bond between them. So as a result, we get a new bond here. So we get CH3 COH CH2 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 new bond. This is nothing but butanol. So we get substituted cyclobutanol, because it is substituted by methyl group. So we call it substituted cyclobutanol. Butanol because it has 4 carbon atoms and an OH group attached to it. So it is cyclobutanol. This is the minor product in this gamma hydrogen abstraction reaction. Let us see another example. Now let us consider one aromatic ketone. This is aromatic ring, phenyl group C6H5, C double bond O, CH2, CH2, CH2 and hydrogen. This is alpha carbon, beta carbon, this is gamma carbon. Gamma carbon has 3 gamma hydrogens. Of that we have represented 1 gamma hydrogen in orange color. When this compound is irradiated by UV light, it undergoes N to pi star excitation and enters singlet state. From singlet state, through intersystem crossing, it enters triplet state. Since it is an aromatic ketone, this cannot undergo pi bond cleavage in singlet state. So it enters triplet state. In triplet state, the pi bond between carbon and oxygen cleaves homolytically to give us an alkoxy radical. This is the alkoxy radical. Meantime, the bond between gamma carbon and gamma hydrogen starts cleaving. As a result of which, this gamma hydrogen is attached partially to oxygen and partially to gamma carbon. As a result of which, we get a cyclic transition state. So, this is given the numbers 1, 2, 3, 4, 5, 6. So, this is a 6-member transition state. This 6-member transition state will form 1,4 biradical. The bond between gamma carbon and gamma hydrogen is cleaved totally and hydrogen gets attached itself to the oxygen radical. So we get 1,4 biradical. This is the first radical. This is the fourth radical. 1, 2, 3, 4. So this gives us 1,4 biradical. So we can say alkoxy radical abstracts gamma hydrogen to form 1,4 biradical. This is the 1,4 biradical. C6H5, COH radical, CH2, CH2, CH2 radical. This is 1,4 biradical. This 1,4 biradical can undergo 2 types of reactions. One is beta cleavage, the other is cyclization. Beta cleavage means the bond between alpha carbon and beta carbon cleaves homolytically to give us a radical on one on alpha carbon, one on beta carbon. This is the beta carbon. So this radical and this radical will join together to form a new bond which is represented in red. So this gives us CH2 double bond CH2. This is ethene. Now here there is a radical already present on this carbon atom. A new radical is formed on this alpha carbon. These 2 radicals will join to form a new bond. So as a result of which we get C6H5, COH, double bond CH2. This is enol. This enol undergoes tautomerization to become stable and forms a ketone. This is acetophenone. Tautomerization means this gamma hydrogen which is present with O will go down here and combine with this CH2 to form CH3. So as a result of which we get C6H5, C double bond O, CH3. This double bond will shift here between carbon and oxygen. So we get acetophenone. This is the major product. Now let us see cyclization of 1,4 biradical. This is the 1,4 biradical. Cyclization means these two first radical, one radical and fourth radical will join together to form a new bond between themselves. As a result of which we get a 4-membered cyclic product. So this is called phenyl cyclobutanol. This is cyclobutanol because it has 4 carbon atoms attached to OH group. So cyclobutanol. Since a phenyl group is attached here, it is called phenyl cyclobutanol. This is a minor product. So the major product here is acetophenone. So these two reactions are about abstraction of gamma hydrogen atom. Now what happens when there is no gamma hydrogen atom? So if there is no gamma hydrogen atom present in the compound, beta hydrogen abstraction reactions occur in the carbonyl compounds. Since no gamma hydrogen atom is present, there is no beta cleavage or Norris type 2 reaction. Only cyclic product is formed. Let us see this compound. C6H5, C double bond O, CH2, CH2, N, C2H5, C2H5. Let us name the compound. This is the first carbon, this is the second carbon, this is the third carbon. So, the second carbon is the alpha carbon, third carbon is the beta carbon. To the beta carbon, nitrogen is attached. So, we call this 1-phenyl 3-diethyl amine propanone. Propanone because 3 carbon atoms are present with a carbonyl group. So, it is called propanone. Diethyl because 2 ethyl groups are attached to this nitrogen atom. So, this is diethyl amine. It is attached to, this nitrogen is attached to third carbon atom. So, it is called 3-diethyl amine. So, this is the compound we are taking. When it is irradiated by UV light, it undergoes N2 pi* excitation and enters singlet state. This cannot give photochemical reaction or photolysis reaction in singlet state because it is an aromatic ketone. So it enters triplet state through intersystem crossing. In triplet state, the pi bond between carbon and oxygen cleaves homolytically to give us alkoxy radical. Okay, this is the beta carbon and this is beta hydrogen. So this is the alkoxy radical, C6H5, C radical, O radical, CH2, CH2, N, C2H5, C2H5. So this is the alkoxy radical. Meanwhile, the bond between beta carbon and beta hydrogen starts cleaving. as a result of which the beta hydrogen is partially attached to beta carbon and partially attached to oxygen atom of the carbonyl compound. So we get a cyclic transition product. So let us number the transition state. This is 1, oxygen is 1, carbon is 2, this carbon is 3, this carbon is 4, this hydrogen is 5. So we get 5-membered transition state. This 5-membered transition state, when this bond between beta hydrogen and beta carbon cleaves completely, gives us 1,3 biradical. This hydrogen will get attached itself to the oxygen totally, as a result of which already a radical is present on this carbon, first carbon atom. A radical will be formed, new radical will be formed on the third carbon. So we get 1, 2, 3, 1,3 biradical. This 1,3 biradical will undergo only cyclization because it does not have gamma hydrogen, it cannot undergo beta cleavage. So these two radicals will join together to form a new bond between them, as a result of which we get C6H5, COH, CH2, CH, a new bond here, and the rest of the compound will remain as such, N, C2H5, C2H5. This is a cyclic product. We can name this compound as 1-phenyl because phenyl group is present on the first carbon atom. 3-diethyl amine, diethyl because 2 ethyl groups are present. Amine because amine is attached to third carbon atom. 3-diethyl amine. Cyclopropanol. This is cyclopropanol because 3 carbon atoms are present here. C 1, 2, 3. 3 carbon atoms are present. So it is propane. All because OH group is present. So it is called 1-phenyl 3-diethylamine cyclopropanol. So in beta hydrogen abstraction reactions we get cyclic product only. Let us consider delta hydrogen abstraction reactions. So let us take the example of benzyl phenyl naphthyl ketone. Benzyl, this is benzyl group. pH CH2 is benzyl group. This is phenyl group. So benzyl phenyl. These two fused benzene rings represent naphthyl group. Ketone because this is carbonyl group. So this is called benzyl phenyl naphthyl ketone. When it is irradiated by UV light, it undergoes N2 pi star excitation and enters singlet state. From singlet state, it enters triplet state through intersystem crossing. Since it is an aromatic ketone, it can react only in triplet state. In triplet state, the pi bond between carbon and oxygen cleaves, forming an alkoxy radical. This is the alkoxy radical. A radical on oxygen, a radical on carbon is called alkoxy radical. Meanwhile, the delta carbon atom and delta hydrogen bond will start cleaving. This is alpha carbon, this is beta carbon, this is gamma carbon, and this is delta carbon. So this hydrogen and carbon bond starts cleaving. So we get a transition state, a cyclic transition state. That is, the hydrogen is attached partially to delta carbon and partially to oxygen atom. As a result of which we get 1, 2, 3, 4, 5, 6, 7. So 7-membered transition state is formed. So later on, this bond between delta carbon and delta hydrogen cleaves totally, and this hydrogen gets attached itself to oxygen. As a result of which we get 1, 2, 3, 4, 5. 1, 5 biradical is formed. So we can say alkoxy radical by abstraction of delta hydrogen forms 1, 5 biradical. This 1, 5 biradical undergoes cyclization. It cannot undergo beta cleavage because there is no gamma hydrogen. So these two radicals will join together to form a new bond between them. The new bond between these two radicals is represented in red ink. So we can name this compound as, let us number the carbon atoms. First carbon, second carbon, third carbon, fourth carbon, fifth carbon. So this is 1, 2 diphenyl. Then this is naphthyl. 1, 2 diphenyl, naphthyl, 1 pentanol, because OH group is attached to first carbon atom. Pentanol because 5 carbon atoms are involved in this ring. 1, 2, 3, 4, 5. So this is 1, 2 diphenyl, naphthyl, 1 pentanol. So this is about delta hydrogen abstraction. Now let's see epsilon hydrogen abstraction reactions of carbonyl compounds. This is also an aromatic carbonyl compound or aromatic ketone. This is cyclodecanone. Decanone because 10 carbon atoms are present in this ring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let us name the carbon atoms. This is alpha carbon, this is beta carbon, this is gamma carbon, this is delta carbon, this is epsilon carbon atom. When it is irradiated by UV light, it undergoes N to pi star excitation and enters singlet state. From singlet state, it enters triplet state through intersystem crossing. Since it is an aromatic ketone, it will undergo reactions only in presence of triplet state. So in triplet state, the pi bond between oxygen and carbon cleaves, forming an alkoxy radical. Meanwhile, the epsilon carbon atom has a hydrogen. Each carbon atom has a hydrogen. So this hydrogen atom gets detached from the carbon atom and gets attached to this oxygen radical. As a result of which we get a new radical here on epsilon carbon, and already a radical is present here. These two radicals will join together to form a new bond. The new bond is represented in red ink. So as a result of which we get a bicyclo product. How to name this bicyclo product? These two rings are present, so it is called bicyclo. Each ring contains 4 carbon atoms. So 4 4. Bridge carbon atoms are nil, so 0. Bicyclo 4 4. 10 carbon atoms are present altogether, so it is decane. 1 all, because OH group is present on the first carbon atom. So this compound is called bicyclo 4,4,0 decane 1 all. This is about epsilon hydrogen abstraction reaction of carbonyl compounds. Okay. So we have seen gamma hydrogen abstraction reactions, beta hydrogen abstraction reactions, delta hydrogen abstraction reactions, and epsilon hydrogen abstraction reactions of the carbonyl compounds. These are all intramolecular hydrogen abstraction reaction because the hydrogen is abstracted from within the molecule. Thank you very much for watching my video. Please subscribe, share and comment. Thank you.